Hey Bengals, it's Ms. Hijik here, and I am going to be discussing topography or topographic maps with you. Let's take a look at your WICs and the essential questions that you need to make sure that you are answering. First, the objective is to be able to interpret a topographic map and also satellite views, which we will do in class. Identifying the landscape feature and the erosion and weathering that might occur to reshape these landscape features. The essential questions will be to define a contour line, to determine how contour lines can be used to help you determine elevation changes within a map, and then be able to also recognize certain landscape features like a hill, a valley, a river, plateau, a ridge, depression, and then you really need to be able to distinguish a gentle slope, one that is sloping up slowly, versus a steep slope, one that slopes up very quickly or has a very quick change in elevation. So let's get started with what a topographic map is, because a topographic map is a map that uses contour lines to help show changes in elevation. You will also hear us refer to them as contour maps because again they use contour lines. And so this is an example of a landscape feature. It's an island, as you can see, and the elevation of this island changes. It goes up to just above 125, we'll say feet, 125 feet above sea level. This over here on the right hand side would be a topographic map of that landscape feature, of that island. So you can see that each one of these lines is a contour line, and all of this first contour line here, that's 0 feet or sea level, and then the next contour line shows a 25-foot change in elevation. So we've gone up 25 feet, vertical change in elevation. And then the next line shows another 25 feet change in elevation. So we are at 50 feet now above sea level. And then another 25 feet when you go to the next line. So we're at 75 feet above sea level. And then 100 feet above sea level. And then finally the last contour line here is 125 feet above sea level. So every time you see a contour line, the elevation has changed by 25 feet. Notice that this hill is higher than 25 feet, but you don't see another contour line over here on the topographic map because it is lower than 150 feet. So this doesn't necessarily, this last contour line here doesn't necessarily say that that is how high the elevation is. It can be higher than that. It just can't be higher than what the next contour line would be. So the next contour line would be 150 feet. So this hill could be all the way up to 149.9 feet. It's just not 150 feet in elevation, because if it was, there would be a 150-foot contour line right there. So we can use these contour maps or these topographic maps to predict elevations and also to identify different landscape features. So let's figure out how to interpret a topographic map. First of all, you need to be able to recognize the contour lines. And the contour lines are these lines on a map, and they connect areas of equal elevation. So you can see this bolded line, this is called an index line. It has an elevation of 800 feet. Or meters, it doesn't really say, so we'll just call it feet. And so all of the areas along this line right here have an elevation of 800 feet. Now down here we have another contour index line at 700 feet. So all of the areas along this line are 700 foot in elevation. Well, how about all these other lines right here? I don't really know what the elevation is of those lines, but I can figure it out if I can determine something called the contour interval. The contour interval is the vertical distance of elevation change between each contour line. So I know that this is a 700-foot elevation, and up here I have an 800-foot elevation. So that is a 100-foot change in elevation across these contour lines, which means to get from here to here, I had to go up 20 feet. So I'm at 720. And to get from here to here, I'm at 740 feet. And then from here to here, I'm at 760 feet. And then from here to here, I'm at 780 feet. And then from here to here, I go up to 800 feet. So this is on this particular map here, this is a 20-foot contour interval. Between each contour line, there is a 20-foot change in elevation. And different contour maps or topographic maps will have a different contour interval. So it's important to first determine what your contour interval is, then you can make some correct interpretations about that map. Now you also need to be able to recognize a steep slope from a gentle slope, and that is really easy because the closer the contour lines are together, the faster the elevation changes and the steeper the slope. If the contour lines are spread out further apart, then the elevation changes more slowly, and that will then be a gentle slope. We can see that, let's find a map that's got a really good, I guess we can see that right here on this map. You can see that on the eastern side of this map, the lines are a little closer together. And then you can see down here in the profile, the side view, that it's a little bit steeper of a slope to get to the hilltop. But on the western side or the left side over here, you can see that the slope is much more gentle. And then you can see here onto the contour map, look how widely spaced the contour lines are. So that means the elevation is changing much more gradually and the slope is much more shallow or gentle. So if I was a hiker, and I don't hike, I would probably want to get to the top of this hill from the left-hand side over here, from side A. Whereas if you were in it for just a really avid rock climbing kind of let's go out there and hike, yeah, experience, then you might want to get to the top of the mountain from side B over here on the right-hand side because it's going to be a lot more challenging because the slope is much steeper. And I can see that by the closeness of the contour lines. So make sure you can identify a steep slope from a gentle slope. Now you also need to be able to recognize hilltops, and hilltops are shown by circles. So you can see that here sea level is 0, and then I go up by 50, let's say feet again. I don't see that it says anything other than feet. So the contour interval is 50 feet. And then right here I have a circle which represents the top of this hill. And then I have another circle over here which represents the top of this hill. So anytime you see a circle on a contour map, that represents the top of a hill, and it's the highest contour elevation at that point. But remember, the elevation can go a little higher. So here that peaks up over 250, and here it peaks up over 150. It just can't go beyond the next contour line. So the next contour line here, if the interval is 50 feet, then this one can't go over 300. You can see that it's between 250 and 300. The elevation is actually 287. And on this side, the last contour line is 150. The next one would be 200. It can't be 200 because that contour line's not there. And so it's got to be somewhere between 150 and 199. And so the elevation is actually 193. So you can definitely make some predictions as to how high the mountaintop or the hilltop could be based on the last contour line and then knowing what the contour interval is. Excuse me. Another landscape feature you need to be able to recognize on a topographic map is a valley. And a valley is shown by a V shape in the contour line. And you can see there's a little set of V shapes right here within these contour lines showing the valley. And kind of see that, you can see that valley right here on the profile as well. So there's a valley, and that's represented by those V's. Here's another valley you can kind of see as these V shapes here in the contour lines. Here's some really good V shapes. These consecutive V shapes like that represent a valley. So wherever the contour lines make that V shape, that represents a valley in the landscape. Now, what travels through valleys? rivers, especially if there's been a lot of rain, then you're probably going to get a river flowing through that valley because the valley is lower in elevation, and so rivers have a tendency to flow through. Now, a river can be recognized on a topographic map by lines running through the valleys. Now, this particular line is a dotted line, which is important. That means that that river is only a seasonal river. It's only there during the rainy season, and when it's not raining, then there probably won't be a river there. If it was a solid line running through the valleys, then that would represent a permanent river, one that is there all year long. And so you need to be able to recognize the direction of river flow. Now, on a contour line, your valley is going to, the wider part of the V is going to be pointing downhill. And so where the V in the contour line opens up, that is the downhill direction. And rivers always flow downhill. So rivers are going to flow through the narrow part of the V and flow through the wider part of the V. So for this particular map down here, this river is flowing southwest. This river is flowing southeast, and they join right here and they begin to move south, and they kind of meander through there and then come down here through point B. So the rivers flow downhill through the opening of the V on the contour line because the V, the opening points downhill, which is the direction that rivers flow. Plateaus are something that you need to be able to also recognize. They're very similar to hilltops, except there's a larger circle that represents the top of the plateau instead of a smaller circle, which represents a more pointy peak. If your hilltop circle is wider, that represents a flatter hill, which is in fact a plateau, a hill that has had the top cut off. A ridge is also a feature that you need to be able to recognize. And I thought I had a ridge on here. A ridge is the top of a mountain, but the top of the mountain is very long and narrow. So it kind of looks like an oval, a long skinny oval that represents the ridge top. And I think there's some examples we're going to look at in a minute that have ridges on them. And then a depression is like a hilltop, except going up, the depression is going to go down in elevation. So you can recognize a depression when the contour line has these little hash marks on it. That represents the elevation going down or decreasing in elevation. So instead of going, so here we have 25 meters and here's 75 meters. So the contour interval is going up by 25. So this is a 50-meter line, 75-meter line, the 100-meter line. But then the next line, the elevation is not going up. So it's not going up to 125. It's actually going back down to 75 meters. And so the hash marks represent a decrease in elevation going down into a crater or a lake or some kind of a depression in the landscape. So, oh, here's a ridge. This is a good picture of a ridge. You can kind of see the ridge here. It's more of a long oval, elongated oval instead of and then you got a little hilltop here, but it's kind of on the top of a ridge. All right, we may have time to come back to that. I've got some good practice questions up here that I want to get to real quick. Let's see how well you do interpreting a topographic map. So go ahead and pause at this time and try to answer these questions using the topographic map here of Mullen Lake. All right, so let's check your answers. Number one, what is the contour interval of this map? The contour interval is 10, we'll say feet. This is a 100-foot line, so 100 to 110 to 120, 130, 140 to 150 right here. What is the elevation difference between point A and point G? Well, if point A is at 100-foot elevation, and that's 110, 120, 130, and then point A is at the 140 contour line, there was a 40-foot change in elevation from point A to point G. Between which 2 points would you find the steepest slope? Between A and G, F and D, or C and B? Well, it's going to be between A and G here because the contour lines are closer together. Therefore, this will be a steeper slope. So the next question is, which direction does the River flow? Well, here's the River right here, and it's flowing through the valleys in the contour line. You can see the V shapes in the contour line, and the river is going to flow through the wider part of the V. So the River is flowing south through the valley until it meets the lake here, the Mullen Lake. It's running off into the lake. Question number 5, which hill has the lowest elevation? So here's hill A, and if this is a 100-foot contour line and the contour interval goes up by 10 feet, then this is the 110-foot, 120, 130, 140-foot elevation. Now it could be a little higher than that, but we'll just say for our purposes right now that hilltop A is 140 feet in elevation. And here's hilltop F. We have an identified 150-foot contour line, so the next one is 160 feet. So point F is around 160 feet in elevation. And hilltop C is right at the 150-foot elevation. So it's hilltop A with an elevation of around 140 feet that has the lowest elevation. And then number 6, what is the highest possible elevation of point F? If this is our 150-foot elevation line, and then we have 160, the next contour line of 170 is not there. So the highest possible elevation of hilltop F is 169 feet. It can't be 170 because if it was, then the next contour line would be visible. But the highest possible elevation is 169 feet. Guys, I look forward to continuing to practice reading and interpreting topographic maps with you in class in the next few days to come. So I'm out.